So today I'm going to try to explain different methods of sharpening, the concepts behind it. So of course we have different types of blades. One most common would be like a chisel or a paper cutter. It has a very unique geometry. It's basically is perfectly flat as you can get it on the top and the bottom, and then there's one consistent edge bevel coming to an apex to the cutting edge here. Now certain chisels for different materials, they'll have either a more acute or more obtuse angle to it, depending on if it's harder or softer. If you have wood or you're working with something a little more malleable, you'll use a thinner blade to have some more precision. Something like rock or concrete is going to be a lot thicker as it steps backwards. Sometimes even the masonry ones will have more of a convex edge, but the consistency of like a chisel is having that perfectly flat bottom and the perfectly flat top and one consistent edge angle going all the way down for the most part. Then when you start looking at like knives, swords, until you start getting into like altering the geometry, for instance, like for the tip of a katana, that's a little more in depth, and that'll be a different video. But the main consistency we're trying to get here is how to establish the actual edge angle and how to keep that consistent. So we're going to start off with a standard edge around 20 to 30 degrees, which is what most knives and kitchen knives and some of the more fine edge swords, that type of thing, they're around 20 to 30 degrees. Axes are usually a little bit higher than that, can go up to like 45 degrees actually, if you're talking about splitting axes. But so a standard blade, this would be the 0 point line right here. This is what you're measuring off of. So this is the apex of your blade. You're trying to come right into the middle. Kind of hard drawing in reverse. Trying to go right into the middle of these 2 points. That would be your 0 degree line. So 0 degrees. And then this line should be at the 20 degree angle relative to the middle of your blade. So for reference, this, couldn't find my regular protractor. This bottom line here, barely see it. Hey, get a little glare on it, you can. All right, so this bottom line here, that's your 0 degree line. It's set at 20 degrees. This, 25, that's 30. So it's a very small movement, but over the length of your edge bevel, it can become significant, especially depending on what the type of edge bevel you have. So if you have a long edge bevel, like this actually has 2 edge bevels, but the edge bevel on this one starts here, this ridge line. So the rest of the material is basically flat at the back. That's essentially what you start with. If you look at a sword blank, it will have the shape front and back on the profile. So for instance, like a spearhead type, whatever it is, it's going to be that shape, and then when you rotate it, it's going to be perfectly flat this way and this way. There won't be a drop here. So when you start making blades from blank flat pieces of steel, it's that center line that you're looking for right there. Now you can get calipers that's kind of like a little measuring tool that slides up and down. It looks like a little pincher, and you can measure exactly. Some of them are digital; they can get down to hundredths of an inch. So you measure exactly how thick your material is, and then you cut that number in half, and then you measure exactly halfway up between this flat and this flat, and you make a line. And then you remove the material from this edge and from this edge at the same rate. So when you get to here, you have a consistent, whatever you decide, the 30 degree, the 25. I like to go with 27, 26 on most of my blades, most of the smaller blades that aren't going to take a whole lot of damage. Come into contact with a bunch of hard things. I like to go a little more narrow, around like 22 degrees when I'm working with like kitchen knives, if I'm going to be cutting fruits, stuff like that. So this is another good little diagram. Unfortunately, it's kind of small for this camera, but so you have the shape of the profile, and then you have the flat bar. So if you're looking at it from the tip, if you raise it up 90 degrees. So if you flip this up, tip up 90 degrees, you basically just see a flat bar, top and bottom, that comes to a point on either side. That is this angle. So the angle of your tip. Some will be straight, some will have a curve. We'll talk about how to deal with the straight and curved edges and keeping that consistency of 27 or 20 or 30 degrees that you want throughout a curved blade. Consistently through a curve is a little bit different than having a consistency with a straight blade. Are pretty simple hand tools. You can achieve a lot with like regular files and everything. So just to show you a little bit of what I would be doing is take your sharpening tool, whatever it is. If I'm starting with a blank, which is basically what this would represent, this is just a bar of spring steel. So if I want to make, let's say, a spearhead, I'll cut this off, depending on how acute or obtuse I want that spearhead to be. If I'm going to be throwing it at something unarmored, like if it's something to hunt animals, it will have more of an acute angle. If it's going to be used against armored opponents, the tip is going to have more of an obtuse angle to prevent damage to the actual weapon. So I'll take that 20 degrees, that zero line is right here. So that 20 degree angle, that's how I'm going to be cutting it off. So this is the 20 degrees. Now you can actually use your fingers on either side of the file as you push it or pull it down the material. A lot of, especially old timers, will say never pull your file back across the material. There's actually been quite a bit of research and like with a microscope showing that pulling file back across the material actually helps the file last longer. So this is like one of the higher, or well, lower grit. It takes off more material. This thing is real rough. You can actually hear a nail going across it. So that will take off a significant amount of material at a time. Then once I have the correct shape that I want, once I've taken each side down and I've gotten the tip profile that I want, cut in the place for the handle to attach, then I'll start using finer and finer files. This one you can barely hear. So you start with the lower grits hand files. Sometimes I'll even start with like 60 grit sandpaper if it's a really big project, and a belt sander. I usually like to do things by hand, so I do have an oscillating an oscillating sander, hand sander. One is cordless, So it's really friggin' handy. A lot of people, they do not do this. They don't go this route. I like to, because number one, they're disposable. Number two, I can basically get my hands on as much of the stuff as I want for free. So using sandpaper, this is about 250 or 300 grit, and this used to be 300 grit, but it's probably around 600 now because it's been used quite a bit, as you can see. And people will argue that sandpaper doesn't last very long. You're constantly having to change out your sharpening equipment. That's not necessarily true. I've actually sharpened 6 full-size boards and a spear with, well, this step of this sandpaper. So as an example of how I would use this, a lot of people don't move your sharpening material, they move the blade. Well, when you have something this size, it's kind of difficult to have your sanding block or sharpening stone or whatever you're using sitting stationary and move this gigantic thing that weighs over 5 pounds. This thing is massive. It's difficult to keep a consistent edge bevel, but you know what does work? This thing is heavy. It doesn't like to move a lot. So if you can get this thing stable, I honestly use my legs quite a bit, especially when you have the ability to rest it upon a bone. It's not going to move very much back and forth. So once I have it stable, now I can just sit here in my chair, and instead of looking to see where this is aligned, I actually set it on there, look just long enough to see where the light disappears between my sandpaper or my sharpening stone and where the apex of my blade meet. I know that's my edge bevel. So once I get that edge bevel, I play with it a little bit, and then I actually feel exactly where that is. And if you use too much pressure, you're never going to be able to fine-tune your senses to be able to do this. But if you have patience and say get a good visual, and then you can feel where this stabilizes, where it wants to stay flat. It's a very small, narrow window, but like it's gonna stay at rest here. If I could balance this thing well enough, I could get it to stay at rest on my actual edge bevel. There it is. So there's my edge bevel. If you can see that balancing point, you can feel that balancing point. Feel where that balancing point is. Right there. Now, that trick from earlier, I can actually use my fingers, feel how far they need to go past the actual sanding block or sharpening stone and touch the spine. Now, as I'm doing this, the spine actually moves away from the blade. So here it's pretty consistent, but as we get to here, I'm gonna have to go off the spine and actually use the body of the blade. Now, how I keep the actual apex of the blade centered with where my fingers are, my index finger is basically going to point exactly where the apex of the blade is. So these are the spacers, and my finger, index finger, is number one, how I sense where that edge bevel is. Number two is going to tell me, as my fingers move along, is that edge bevel going to be consistent? So as I move the sanding block or the whetstone down the blade, as I do this, and this is only on smoother, when you're actually setting it, it's faster to sharpen straight down, but you remove a lot of material, and if you're not careful, you'll mess up the edge alignment, edge bevel. So once you get that nice, smooth, long stroke, you can actually start to feel where the blade has certain sharp or dull spots. Now, if you can hear well enough, awesome. I can't. But there is a trick where, whether it's with a sharpening stone or with a sanding block or any other material, the same thing with, I'll do it all in the back of it, it makes a sound. If I hit both the spine and the back at the same time, it's kind of raspy. But if I lift off the spine and come just, or off the flare and come just to the spine, it has a higher pitched sound. Now, if I change my alignment of this file as I'm going down the spine with blade or wherever, it's going to make a specific pitch, a specific noise. So if you can tune in, if you're good enough at hearing that, you can actually listen that sound will fluctuate when your edge bevel moves. If you can keep a consistent sound, that's another indication that you're moving the material the way that you're intending to. Another thing that you can use is light refraction. There's a reason that I have two light sources on either side of me, because if I look at the blade in certain light angles, I can see the refraction of the light on the edge. Now, every time I move this, any type of sharpening material across, is going to change how that material reflects. So you can actually see exactly, like as you move down the blade, let's say you have some, like this has a little bit of rust. It's been sitting on the wall and it's basically cast iron. So have an advantage here. You can see the little bit of rust right there. So as I go down, I can see where the rust has now been removed from a small portion. I want that small portion to be as close to the middle, because this is somewhat of a concave yet convex edge. It's rounded. I got it basically to where it's more or less flat on either side of the edge bevel, but not perfectly. So it is a little rounded. When I'm taking this convex edge and I'm making a flat edge bevel on either side, a good indicator is when I see that the edge is away from, there's a bit of a gap between my sharpening material and the actual cutting blade, but it's still relatively flat. If I move down through here, I know I'm taking the apex of the hump, not the actual cutting edge, but the hump coming up to it. I'm taking that down. So the wider that gets, the blank space between the top of your edge bevel and the actual cutting edge, the wider this gets, the more on point you are. I'm gonna get to a little section right here. I can actually show you a little better. Oh, this thing's huge. That's what she said. So, get a little bit of light refraction. I can see that there's a little bit of dusting of rust right through here. So I can use that as an indicator as I move down the blade. And I'm getting consistent removal of rust between right here and just below the actual cutting edge of the blade. So I know that rounded part. Get the bag on out. So I know I'm flat against this rounded part and I'm making it more of a straight edge. So if I'm here and I'm moving the material along the blade, the edge of the blade, I'm taking out just the very top of that rounded part, making it straight. Now, to get a convex edge where it actually dips in and then comes to a point, that's a lot more difficult. Once you get, here's an example of one. So the blade comes in and then comes back out just a little bit and then has a secondary edge bevel to come to a point, to come to that apex. Same thing with this little ooey knife over here. This is a little more fine, but you can't really see it very well, but it actually dips in, comes back out, and then to a point. So that's a different type of edge to work with. Again, that's gonna be a different video. Just some quick notes on that. Most people cheat doing this. I'm gonna show you how to do it by hand in the next video. The way they, quote unquote, cheat is they take this and they have a spinning wheel, and just below, or just above the cutting edge, they just remove the material with that spinning wheel, back and forth, until they have a groove on the flat side on either edge. And then they take a honing stone or maybe the same type of a polishing wheel or whatever, and then they go back and they refine that last little 1/10 of a millimeter at the edge there to make it come back to an apex. These are really difficult to maintenance without messing that double edge bevel and concave bevel up. It's very difficult. So a quick little example. Normal standard kitchen knife. It's somewhat sharp, but it's somewhat sharp, but it's not like super duper sharp. This thing used to be a heck of a lot sharper. Like, it cuts paper, but it does it kind of rough. So it's pretty sharp. It's definitely workable sharp. Definitely work sharp. Beyond work sharp. Can't quite shave hair though. It'll pick a couple of hairs off, but not really shit. So now this, again, is not a very high grit. This is like the very base of what I use to like the very end of what I use to remove material. And this the very beginning of what I use to start the honing process on the blade. So the honing process, like if I'm trying to get an edge bevel, again, if I'm trying to get an edge bevel, let's say this is a chisel. If I'm trying to get an edge bevel, first thing I'm gonna do is start working the material this way throughout the entire sharpening surface. Like, this doesn't really make sense, but you can use it that way. I would use it this way because you're getting the entire length of the block or the sharpening stone across it, and you're focusing more of the weight or energy or potential to take a microscopic amount of material away from your actual chisel. It'll remove more material this way than it will this way. So that's the reason I like to have it straight on. But once I've got the actual blade, and you can call it a blade, and let's say after a while it starts getting dull, that's basically what happened with this. Between cheese and chicken and steak and stuff like that, it's starting to lose the sharpness that it came out the box with. So just a small amount of time. Again, this is around 600 grit, between 600 and 700 grit. Again, just using my leg, the little knob at the top of my knee, I use that as a block. So that, plus it also helps keeping my edge bevel, especially on thinner knives, because I can't really fit my fingers as a spacer and as a point of reference onto this tiny blade. It's not really doable. So I used my actual leg as the guide. So I get my edge bevel, and then I set it on my thigh. The knee bone itself is basically like a block, and then the skin of my leg is what keeps the knife in place and the correct latitude. Then I move the sharpening material. Let me see if I can. Not really. I think I got some. So once I'm here, I'll put the sharpening stone or block or whatever. Like I said, most people like to do it this way. And I like to do it this way too. We use the entire block. This is a really easy way to get the entire blade consistent. But sometimes, if you're mobile, sometimes you just don't have a setup. Sometimes the best thing to do, especially if you have a massive sword or spear or some other giant piece that you're trying to sharpen, you can't just use a whetstone. This is a 1500 grit whetstone. As you can see, it's got quite a bit of rust on it. It's water bath dried up. So to use this whetstone, like if I were to put it on the floor, it's not going to be perfectly flat. If I put it on anywhere without a retainment system, it's going to want to move anyway. So doing this, I like to go point to base and base to point, both ways. And as you can see, this thing likes to rock. When you put it on something relatively flat, you can kind of work with it. But if you're trying to move a lot of material at one time, it'll start sliding around, especially when you have a bunch of water and a surface that's not particularly grippy. So it's always good to have techniques that you can use when you don't have the proper setup. This is one of those techniques. Using my knee, get it up here a little bit higher. Using my knee, I get the correct angle, and I try to get the bone of my knee in the middle of the blade, so it's supporting both the tip and the base, or 2/3 of the way up the blade, and it's supporting the base and the tip relatively evenly. Then I find my edge bevel. Once I find my edge bevel, then I can use the fingers on my leg and the one finger on the back of the spine of the blade, and the edge actually, instead of being straight, it moves. So to have my finger as a guide on the back, I'm gonna have to angle my block. Instead of coming straight across, I'm gonna have to come across like so. You follow that arch. But you can also use your finger to keep that edge bevel along the arc. Do a nice slow fluid stroke, starting off on one side all the way down to the tip. If you have to, start over a couple of times in the places of the blade that you feel, because it's not going to wear away the same every time. Especially in the higher grits, you're going to feel where there are catches. When you feel those catches, don't be afraid to go over that little, like there's a catch right there. I'm going to go over that, just that section of blade, lightly, until that catch feels, there we go. Now it's not dragging, it's not bouncing around anymore. Now it's feeling consistent. You can see that edge bevel is nice and consistent. Nice smooth strokes using the entire face of the sandpaper. At least on this half of the block. to the tip. Got a little bit of resistance right here. We're gonna focus right there for a little bit. Now remember, you don't have to bear down a lot. This is just moving a harder material across a softer material. It's going to take steel away. You don't have to grit your teeth and try to push this thing through your knife. Just let it slide. When it's sliding across your knife, you can feel little bumps, like driving down a smooth, nice, cleanly blacktop road with new shocks, like riding on a cloud. When you go down a gravel road in that same vehicle, you can feel all the bumps. You can feel that in here. And then the higher grit that you get, the more minute those bumps are going to become. So you have to become more and more sensitive. It is really prevalent in sharpening stones. That vibration effect, because the sharpening stone, the material being much harder all the way through, it transfers that vibration much better than through wood. So this has actually taken me quite a long time to get the same level of efficiency. Ooh. There we go. That was pulling hard. All right. Now I'm feeling almost no resistance when I'm using the consistent angle and a nice slow, smooth drop, nice smooth stroke throughout the entire length of the blade. I'm feeling no spot where it feels harder to push my sharpening stone through. So that's when I turn it over. I do the same thing on the side. With this, you don't have your back finger on the spine this time, so you get your consistent edge angle with the feel of your fingers and where it gets flat. And from there, ooh. I'm checking the back apex of the edge bevel, and I'm checking the front to see if they're a consistent width. If you can have the ability to see where the edge bevel starts and where it ends, if it's consistent width from here to here, all the way down the length of the blade, that's cheese, all the way down the length of the blade, you know, you at least have a consistent edge bevel. Another couple things: pushing away from the blade. You want to push away from the cutting blade, away from it. Now, if you pull towards the cutting blade, you're gonna be cutting in, especially sandpaper. But if you're good enough, most people will scream at you if they see you doing this. You can actually go along and down the length of the blade, as long as you're careful, and it'll help deburr. So this is one of the techniques that I use to help the first round of deburring. And as you can see, I'm doing it at an angle. Same concept as going away from the blade. Keep that same angle and just feel for any type of spot where it pulls extra. That's gonna give me a nice, tight, consistent deburred edge on that side. from the cutting edge. All right, so now that we've gotten each side done, again, going away from the blade, trying to keep that consistent. Completely by touch to feel if there's anything catching as I'm moving it along, if it slows down or if it feels jittery or jagged. Tiny little bit there at the tip. All right. So now I could go higher in grit and have less work to do on the strop, but it doesn't really matter. So the way I make my strops is this is from a double-ended belt, basically a flat piece of wood, a couple of staples there, one on the back side, nice and taut. Same concept, working away from the blade. Consistent edge bevel, edge angle. Consistent angle is the number one thing. A few passes on the strop. And again, you're feeling, not a lot of pressure, you're feeling if there's any spot where that edge wants to catch or slow down. When you feel an increase in friction, when you feel a bump, that means there's something along this edge that needs to be smoothed out. All right, one more on the side. I think we're groovy. Now, same piece of paper from earlier. Much cleaner cut. Very little time spent on this one knife. I was talking the entire time, basically. Even at the base. So it does not take much time. It just takes the knowledge of how to do it, the patience to learn the skills necessary, and of course the patience to actually sit there with your eyes closed for hours on end, trying to feel both the edge bevel correctly and that slight vibration. When you start working that vibration and those catches down to where you can close your eyes, there's the edge bevel. I can close my eyes and I can feel that edge bevel without opening my eyes, and I can use that angle all the way down, and I feel nothing. I feel no stopping, no increased friction, and again, it still has cheese on the blade. This isn't a clean blade, but it still performs. So apexing the blade is in my opinion is more about touch, knowing exactly what's going on at like a microscopic geometric level, and refining your sense of touch to that degree is how you get to the point where you can turn a butter knife into a scalpel.